Welcome back, and we're looking at example 2 in our notes for the unit circle. And on the front of the booklet, we looked at the quadrantal angles, the pi over 2 reference angles. In example 1, we did pi over 4 reference angles. Now we're going to look at the pi over 3 layer. So recall that there are 2 pi radians in the whole circle. If I divide the circle into 6 congruent sectors, each one of those sectors measures pi over 3. So I would be starting then at 0, and 1/6 of the circle is 1 pi over 3. So then this would be 2 pi over 3. Half the circle would be 3 pi over 3, which reduces to pi. Then 4 pi over 3. 5 pi over 3. And 6 pi over 3, which reduces to 2 pi, and that's one full revolution around the circle. So 6 pi over 3 reduces to 2 pi, 3 pi over 3 reduces to pi, and that would be my pi over 3 angles in radians. Okay, there are 360 degrees in a circle, and if I divide that into 6 congruent sectors, each one of those sectors measures 60 degrees. So this would be 0 degrees, then 60 degrees. 2 times 60 is 120 degrees. 3 times 60 is 180 degrees. 4 times 60 is 240 degrees. Then 5 times 60 is 300 degrees. And 6 times 60 would be 360 degrees, which is one revolution around the circle. Now, if I want to find the coordinates of these angles going around in the counterclockwise direction, at 0 radians, because the radius is 1, that's my point 1, 0. Then half the circle, or 180 degrees, pi radians, that's the point -1, 0. And you'll notice that the y-axis isn't part of dividing the circle into 6 congruent sectors. So we don't need to label our quadrantal angles along the y-axis in this layer. So we do want to find the coordinate for the pi over 3 reference angle in quadrant 1. And if we create a reference triangle by dropping a perpendicular down to the x-axis, and we pull that reference triangle out here to the side, this point, the coordinate that we're looking for, is x, y. The horizontal distance across the bottom, that's x. The vertical distance is the y, and the hypotenuse of this right triangle is the radius of the circle. And since it's a unit circle, that radius is equal to 1. So now I can recall that this is a central angle of 60 degrees. And it's a right triangle, so we have 90 degrees, and 60 degrees makes this remaining acute angle 30 degrees, because there's 180 degrees in the whole triangle. And the 30, 60, 90 rule from geometry reminds us that the short side of a 30, 60, 90 triangle is half the length of the hypotenuse. The long side is square root of 3 times the short side. So if my short side is half the hypotenuse, that means the short side is the one opposite the smallest angle, is going to be half of 1. So my x-coordinate of the ordered pair is 1/2. Okay, then the long side is square root of 3 times the short side. So the long side is the one opposite the 60-degree angle, and square root of 3 times 1/2 is square root of 3 over 2. And that is the y value of my coordinate for the reference angle pi over 3. We call it a reference angle because whenever I reflect this reference triangle into another quadrant, the ordered pair's magnitude will stay the same. It's just the sign, whether it's positive or negative, of each coordinate will be different depending on the quadrant that I'm in. So if I reflect this reference triangle into quadrant 2 at 2 pi over 3, that's the quadrant where x is negative, but y is positive. So I have a negative 1/2 positive square root of 3 over 2. When I reflect that reference angle into quadrant 3, now I'm at 4 pi over 3. Both x and y are negative there. So I have a negative 1/2 and a negative root 3 over 2 as the coordinate at 4 pi over 3 or 240 degrees. If I reflect that reference angle into the fourth quadrant, that's where x is positive, but y is negative. So I have a coordinate of positive 1/2 negative root 3 over 2. So that would be the radian measures, the degree measures, and the coordinates for the pi over 3 reference angle layer of the unit circle. So on that template that we've been working on, okay, now we're going to practice filling in the pi over 3 layer. And once you have that filled in, then go ahead and add in your quadrantal angles and your pi over 4 angles, and you'll see how much we've got so far. Okay, so counting in degrees around the circle, we start at 0 and go to 360 for one full revolution. Half of 360 is 180. Half of 180 is 90. And then this would be 1 times 90, 2 times 90, 3 times 90 is 270. Then to get my 60-degree angles, this would be 0, 1 times 60, 2 times 60 is 120, 3 times 60 is 180, 4 times 60 is 240, then 5 times 60 is 300, and 6 times 60 gets us back to 360. Then my radian measures are 0 and 2 pi for the whole circle. Half of 2 pi is pi. Then going in 60-degree angles, that's equivalent to pi over 3. So this is 1 pi over 3. This is 2 pi over 3. Then 3 pi over 3, which reduces to pi. 4 pi over 3. then 5 pi over 3, and 6 pi over 3, which reduces to 2 pi. Then my coordinates for the pi over 3 reference angle in quadrant 1, that's an x of 1/2 and a y of the square root of 3 over 2. Then we reflect that into quadrant 2, where x is negative and y is positive. So this is a negative 1/2 positive root 3 over 2. Then in quadrant 3, both x and y are negative. So this is going to be a negative 1/2 negative root 3 over 2. And then at 5 pi over 3, now we're in quadrant 4, where x is positive, y is negative, and our coordinate is positive 1/2 negative root 3 over 2. So those would be the pi over 3 angles. Now we can go back in and do our quadrantal coordinates. So the center of the circle is 0, 0. The radius is 1. So this is the point 1, 0. Then 0, 1, negative 1, 0, and 0, negative 1. In radians, 90 degrees is pi over 2. And so that's 1 pi over 2, 2 pi over 2, which is pi. 3 pi over 2 is 270 degrees. And then back around to 4 pi over 2, which is 2 pi. Then we can go in and fill in our pi over 4 reference angle. So this is 1 pi over 4. Then 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4 is pi. Then 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. And then 8 pi over 4 is 2 pi. In degrees, pi over 4 is 45 degrees. So we have 1 times 45, 2 times 45 is 90, 3 times 45 is 135, 4 times 35 is 180, 5 times 35 is 225, then 6 times 45 is 270. Then 7 times 45 is 315. And 8 times 45 is 360. That leaves us with just our coordinates for the pi over 4 angles in quadrant 1. Both x and y are positive, so that's a square root of 2 over 2, square root of 2 over 2. Then we reflect that into quadrant 2, where x is negative and y is positive. So negative root 2 over 2, positive root 2 over 2. Then we reflect into quadrant 3, where both are negative. So negative root 2 over 2 for the x, and negative root 2 over 2 for the y. And then in quadrant 4, the x is positive, but the y is negative. So positive root 2 over 2 and negative root 2 over 2. And now we've filled in all of our special angles on the unit circle in degrees, radians, and coordinates. with the exception of 4 angles, and that would be this one, this one, this one, and this one. And those 4 angles we'll be looking at in our next video in our pi over 6 reference angle layer.